Hello there, it's Jay here from Jay's Vintage Junk, and as we've probably not guessed already, we're back on with the Vtech 386 laptop, and I'm pleased to say I've made a little bit of progress with this thing. First of all, someone actually suggested I tried a different PS2 keyboard. I tried this Microsoft one, and this works perfectly with it. It's a really weird thing, because that old Vtech keyboard has just been my general go-to PS2 keyboard when I've needed a PS2 keyboard, and it's worked every single time, so I haven't got a clue why it wouldn't work on this laptop. Interestingly enough, this used to be the keyboard on my Bridge PC up in my office, and I took this off and actually put the Vtech one on there, and it works absolutely perfectly on that computer. But this works with the laptop, so we can actually do testing, do some more diagnostics and stuff without actually having to have the top of the laptop like perched on here in a dangerous way. More so, I've actually got the thing booting. I've got a compact flash card in there. Basically what I did is I used my 486 PC up in my office, and I took the adapter out and used a 44 pin to 40 pin IDE adapter, plugged it into that computer, and then just used my MS-DOS 5 discs, installed, formatted F-disk the compact flash, installed DOS 5 on there, pulled it out, put that into my Bridge PC where I've got all various bits of MS-DOS software and things, nice interesting stuff to run. Put some stuff on there we can actually have a play with, put it in here, and I'll show you. I'll get you up on the screen. Ooh! Right, where have you gone now? There you are. Now, is that the right screen? Okay. That's the one that I want you to look at. I noticed on the other one that the focus wasn't exactly brilliant, so I will try a little bit of effort in this one to see if I can get that a little bit better. Anyway, we'll switch on, and we will have to go through the setup procedure, because I don't think that battery is going to have held any charge. Battery was completely flat, and it is a rechargeable cell actually, so technically it should be able to recharge, but I don't think it will do. Let's get through this then. I think I've got the hard drive set to auto detect actually. Yes, we have auto config there. Now, are you getting this time? I just saw in the last video this wouldn't actually come up on the screen. I don't know whether this is going to work or not. Auto config, yeah, it's found that. Escape from there. Escape, yes. And hopefully this should actually boot. Press escape to skip through the memory test. Otherwise it does take quite a bit of time. Now that's normal. We'll go back up to this screen, and there we go. We've booted into DOS. I'm going to do a DIR, and basically we've got MS-DOS version 5 on here. I've also put just some stuff to play with, really, just for messing about. So we go to CD DOS test. I've got a few games on here, just the usual stuff that is handy for testing, really. Some of this stuff's a bit, like Alley Cat, that's more for like XTs and things, but it was here anyway. We've also got DOS Bench, which was, if you ever watch any of Phil's Computer Lab, the YouTuber Phil's Computer Lab, it's something that he put together. It's basically just a suite of DOS benchmarks for these old computers. I've not actually tried it, I just downloaded it. I've played about with some of the software that's it comprises of before, but I thought I'd give it a try on here and see what it does, so I just unzipped it and literally just dropped it across because I had it on the bridge PC. But also we've got Wolf 3D and we've got Doom on there as well. So that, in fact, let's have a play with a couple of games, just see how they're going to run on this. So let's try Wolf 3D first, because that Wolf 3D is pretty well suited to this era of computer. So yeah, that should work. And that looks fairly reasonable. The graphics don't look brilliant, but I think that's this monitor. This monitor doesn't like the old VGA signals. It is a little bit on the flickery side, and I don't think that's really to do with the computer. I think it is more to do with this monitor. We tried that by trying it on an old VGA CRT monitor, to be fair. As you can see, if you look at the... It shouldn't be all flickery like that. That should be a fairly decent flat blue background there. We've got a little bit of interference on that. I say it's probably the monitor that more than anything else. New game. Obviously we've got no audio. This doesn't have a sound card built in or anything, but what we just want to see is how well it's going to actually load. And that looks pretty good. Yeah, it doesn't look bad actually. I suppose what I could do for stuff like this, I mean, this will run reasonable on a like a 386 SX16. So I mean, an SX33, this is plenty. What will really challenge this is I'm dead. Right, that's a good time to finish this bit. Let's get out of there. But that runs nicely. Like I said, what will probably it would probably struggle with is something like Doom. Doom should technically run on this, because I used to run Doom on a 386 SX25 laptop with 4 meg of RAM. So this is an SX33. So let's have a quick look. That's not looking very good. You really can't see any of that, can you? It's... I don't know. Try to bring that. There, that might have gone slightly better. But essentially, yeah, Doom is going to really struggle on this. As you can see, the frame rate there, it can't handle it. But I mean, you can play Doom on a computer like this. Like I say, I used to. What you have to do, if we go down to options, we'll turn the detail down to low, and we'll bring the screen size come even one smaller than that possibly. Let's see what that's like. I think that's actually crashed it. I'm getting no keyboard activity there. It obviously didn't like Doom. Although it seems to be running, but I'm getting absolutely no keyboard response whatsoever. Yeah, so I'll have to do a reset, I think. We do actually have a reset, I think. Yeah, we do. Let's see if it's going to boot back up, and then we'll just run a couple of diagnostics or something. Oh, let's have a switch off and a switch back on, because that doesn't seem very happy. Oh, there we go. Let's see if it's going to boot back up. We'll probably have to go through the whole setup procedure again, like I said, because it can't save its settings at the moment. Oh no! Amazingly, it looks like it has saved its settings. So I wonder if that battery is not completely shot then. It will have to be replaced. I wouldn't like to trust a battery like that after all this time, but so we want CD DOS test. And then we won't bother with the more games. Let's go to DOS bench. And we will type more. No, it didn't work. Okay. I don't know what I've done there. That's not obviously not worked. Let's do a reset. In fact, I'll come back as soon as it's booted back up. Oh, let's just see whether it's going to actually. Yeah, it's going to work. There we go. Let's go. CD. DOS bench, DIR, and we let's try choice this time. Oh, CD. Let's see what this does. Choice, yes or no? Well, yes. Okay, that doesn't work. Right, let's try this. CD. So we've got all the tests here. What I've done before is basically just pull the ones that I wanted to use just out of here and use them like that. Let's try top bench. Although it might be a bit new for this computer, let's try it. Oh no, it seems to be running. Let's try benchmarking. I haven't actually, like I said, I have. Right, okay. So it looks like it's a bit slow for an SX33 really, if you show what it's actually. It's coming up as 25 megahertz when it should be a 33 megahertz CPU. If you look, it's coming up Dell. This is basically what it's comparing against a Amstrad Mega PC 386 and a Dell 386 SX25, a Tandy 386 SX25. Like I said, considering this is meant to be a 33 megahertz CPU. Let's quit that. So I'm not familiar with this software. 16-bit real-time benchmarking, okay. Right, so how do you quit out of it? There you go. Right, so CD dot. We'll do one more benchmark. So I'm just interested. I'm just let's see what we can try on here. Let's try 3D bench, although that's probably going to be quite ambitious for this. See if this is actually going to run or not. It can run it, but yeah. suppose that's not too terrible, really, for a 386 class machine. In fact, it'd be interesting to run that on my 486 SX25 and see how much difference there is. We'll let it run out. So we've got a benchmark of 8.6 frames per second. So yeah, I think what I will do is I'll probably have a play with my 486 and see what that comes up with. I don't suppose that's too terrible. Anyway, that wasn't really what all this video was about. What the video is going to be about, oops, let's get you down, is basically what problem we've got now is I still can't get that floppy drive to do anything. I did have a rummage up in the attic and I did dig out a couple more laptop style floppy drives. Unfortunately, neither of them are, these are probably compatible with one another. They're a slightly later iteration, basically. Same pin out. I think it's 24 pin or 26 pin. Yeah, I think it's 26 pin. They're both the same. In fact, that's 26 pin as well, but that is a much wider 26 pin connector than those use. Now, if it's all the same actual standard, which I have a feeling it is, we could possibly make an adapter up, but neither of them drives are really physically the same. I do have, which will probably actually make a really nice external drive for it. I do have this one as well. This come off another scrap laptop, about the same era actually. The cable will be no use, but that's again, that is actually the same pin interface as that. I did try it. I couldn't get it to work, although with this on, when it did actually spin the disc, which that one's not doing. The problem is that we won't be able to use this anyway. Because the little connector is basically where it's on this side on this disk drive, it's actually closer to on the exact opposite side on this, and that cable would not reach. So even if that did actually physically work, it wouldn't be any good really for this problem, which basically leads us to the fact that we're going to have to crack into that floppy drive and actually see if we can do anything with it, see if we can repair it or not. So I will, I'll switch the computer off because there's no point having it powered up. In fact, what we'll do is we will take the floppy drive out of here, and then we can get the computer out of the way, and we can just have a play about with the actual floppy drive itself. So I'll get that disconnected. Right, there we go. We'll get that. Get that shut off. In fact, I'll just pause the video a bit and I'll get us reset back up. Right, okay, so we've got the drive actually stripped out of the computer and I've got it here now. First thing I want to do, I'm going to remove this little ribbon cable because I don't want to risk damaging it. So we'll put that with the actual computer. So next thing, we need to take some of this metal work, which is actually to do with the computer in question. It's just the bracket that holds it in place. We want to make sure we keep that safe as well. Put that out of harm's way. Right, now we've got the actual drive, and again we've got some plastic here which is specific to the drive, to the actual computer, so we'll put that there, and there's the drive itself. And I think this is a fairly standard drive, despite, like I said, the fact that it's a laptop drive. Like I said, I think it's fairly standard. Now the problem is, I think any issues it's going to have, it might just be a bit of hardened grease, but let's see if we can get this. got a screw under that tape there. Now I don't think this is going to just be as simple as some dirty heads, because it's not trying to even spin the disc. At least the other one I tried did spin the disc. There we go, that's coming off. There we are, we're in. I was hoping to find some surface mount capacitors in there which could have leaked, but I can see just standard electrolytics in there. But we will. I think what we'll have to do is we'll have to get a little bit further into the drive. In fact, does there look like there's some corrosion around the legs of that IC there, which is right next to that capacitor? That definitely does look a possibility. One problem we've got is this thing looks incredibly difficult to actually disassemble. It's not going to be an easy one to work on. Not like you know, an Amiga drive or something like that, which is fairly easy and fairly accessible. In fact, I'm not 100% sure what I need to take off to actually get down to. In fact, what I might do first is I might just warm the soldering iron up and do my my little touch test around those capacitors and have a little bit of a smell and see if I can actually smell anything untoward, which would indicate that perhaps we do have a leaky capacitor problem. I mean, the head is actually really free to move on its runners. That's not all seized up like we sometimes find. In fact, the grease is still nice and greasy in that. Let's just see if the yeah, and the main motor that actually turns the disc, spins the disc, that's not seized. It's free to turn. I'm just seeing if I can spot any surface mount electrolytic capacitors on the actual motor board without having to take the whole thing apart to see. I can't spot any. Right, now the soldering iron should be nicely warmed up. I'm going to very gently move those wires that go to the head out of the way, otherwise I risk perhaps catching one with the soldering iron. I don't want to melt them. I'll just hold them back like that with that cotton bud. There we go, that's out of the way, so I can basically get in with the soldering iron. Make sure we've got nothing on the end of it, because we just want to use the heat. And I'm just going to play it round the bottom of this capacitor. Warm the board up. And then have a quick smell like that and see if I can actually smell that rotten fish smell, which would indicate that we've got a leaking capacitor. Now I'm not getting a single whiff of that really strong fishy smell, so I don't think that's what the issue is. We can do the same around this capacitor. And again, I don't get that strong fishy smell that you associate with a leaking capacitor. So I think we're probably going to have to go a little bit further down in this. Unfortunately, what we do have is we've got a big IC under there, which probably basically got most of the control for the disk drive in it. And if that's what's at fault, there's probably not a lot we can do with this disk drive. But anyway, I'll get it a little bit more torn down, see if we can actually spot anything, and I'll come back to you if we find anything. So back in a sec. Right, okay, I've got the disk drive connected back up to the actual laptop. Well, this is quite interesting. What I've done, I've basically just wound the heads forwards like that. So what should happen now is when I apply power, the head should basically seat back to track 0, and we're getting no activity at all. If I switch the laptop on, and the laptop will all fire up and boot up, no problem. But as you can see, we've got absolutely 0 activity on the disk drive at all. Now, what would be interesting actually, we'll get the jolly old multimeter in here. Get that set to 20 volts. I'll just get the laptop to boot up so it's actually, the laptop's booted up. We need a ground connection. We can let's use that as a good ground. That should give us a good ground. Right, let's just try on that battery there. That should, yeah. So that shows us we've got a good ground. And let us see if we can find anything actually on the unfortunately I can't get to all the pins. There's our 5 volts going into the drive, or close enough to 5 volts going into the drive. So it's definitely getting power to the actual board. Anything on there? Let's just try that. Yeah, there's our 5 volts, or 4.6 volts. It's a little bit low, but it should still be able to do something at that. And we're not getting anything. We're getting no activity off that disk drive at all. So it's not even trying to spin the disk. At least the other drive that I, in fact, yeah, just bear with me a sec. I'll get the other drive out that I was playing with this thing, and we'll just quickly, because that didn't work either, but we got a little bit more activity out of it than we did from this one. So back in a sec. Right, okay, this is the other drive that I have. This is a Mitsumi drive. It's probably around, like I said, it's probably around about the same date, and it uses the same edge connector there. And I say I don't know, but I'm hoping that this is actually going to be pin compatible with this one, even though it's not actually physically compatible. As in, I don't think we get this to work in the computer because it that cable is wrong. I don't think that we'd be able to get it to work with that cable, but for testing purposes it might do. But basically I'll switch on. Now, I did hear that just spin up very, very briefly as it started up. We'll get the computer back up. Just getting the computer to boot up. Right, there we go, that's the computer booted up. I'll put the disc in. And straight away I heard the disc actually spin up, but at least that's a little bit more progress than we got with the other drive. But if I type an A colon, it doesn't, like I say, it's not bringing the light up as though it's showing drive activity. There's nothing there at all. But I can actually hear the disc spinning in this one, which we weren't having them happening in the other one. In fact, I wonder if we could just try that quick experiment. What we'll do. So I have to be super careful as well because I don't want to risk damaging that cable there. What I will do, we'll get the top off this one. don't think there's any screws holding that, is there? We should just be able to just pop this top off. Come on, off you come. What's holding that? There we go. Oh, and that I can see some surface mount electrolytics in there. There's a one right down there. What is it? It's 47 at 16 volts. What I thought we'd just try is basically what I was trying on the other one. We will bring the head forward like that, and we'll switch on and we'll actually see whether it's going to seek the head back when we apply some power, which will at least indicate this has got a little bit more life than the other drive. So let's give that a quick try. Unfortunately not. So the computer's powering up and everything, and I can hear the motor going. I can actually hear the motor running on this one. At least I think I can. Well, I can hear it trying to run. It's like making a t-t-t-t-t noise. Let's switch that off. You get this disconnected again. And we'll get the again, I'll just pause you while I get the computer out of the way. Okay, right, and basically we're just going to do the smell test on. Let's get that disc out there so we don't risk damaging the disc. Can I see any more in there? No, just that one there. But let's just give the smell test to that. In fact, let me get something I can pull them out with. I want to just quickly move those out of the way because I don't want to risk catching them with the soldering iron. So pull those out of the way and just tuck them up all the way out of there, just so we can get into that that capacitor, and we'll do what we did last time, and we'll just do the sniff test. Just warm it up round it. Oh god, yeah. Oh yeah. That's a bad cat. It absolutely reeks of electrolyte as soon as I did that. So could that be why this one is not this one's not doing anything? We've definitely got one bad capacitor there. That's going to be an absolute swine to change as well. Unless we can get the drive apart. In fact, just bear with me a second, folks, and I'll just figure out what and how I'm going to actually tackle this. So, back in a sec. Right, this is going to be fun to do. Basically, here's the problem. These drives were never designed really to be repaired. To get to the actual capacitor, I'd have to take out all this. To do it properly, we'll have to take all this out, which it basically means dismantling the entire floppy drive, and even then I'm not sure I'll be able to get this thing back together. What I did think is there might be another approach how we can at least take that capacitor out, clean up round there. We've definitely got capacitor leakage. I can't see any other electrolytic capacitors which are likely to cause issue anywhere else on the board. Not on the motor board. In fact, let's just have a quick squiz in there. I can't see, just by you know, rotating it round like that, any other problem capacitors. It's just that one at the back there. I can't see any looking through in there. So I don't recommend this at all in any way, shape or form. But what I'm actually going to do, I'm actually going to twist it off. Well, no, I'm not going to twist. What I'm going to do is very gently. In fact, that feels like it's just going to go straight away. I think the legs on that are very rotted. So I don't recommend taking capacitors off this way. I generally use the soldering iron or heat. The problem I've got is I can't get on to that side there with the soldering iron. I can't use heat because I've got lots of little resistors, tiny little resistors round it. I can't mask them off. So I think just very gently. You see, I'm not being violent with it. I'm not literally twisting it off. I'm just gently rocking it side to side, and I'm just hoping just to fatigue the legs without actually ripping a pad off the board or anything. It is actually off on that side. It's only this side holding it now. Again. There we go. Get the base bit there off. There we go. And I can see how bad the dear me, that's nasty under there. That's really been leaking. So we're gonna have to do a clean up before we do anything else. Get some IPA. Now I'm not saying this is going to fix it, but it's worth a try. And see if we can get any better results from this drive. So it's just a shame that I don't think we'd actually be able to fit this drive in the computer, but if we can get it to boot from this drive, it proves that the drive electronics in the actual computer are good, and then we can figure out what we're going to do. The problem is that other drive, it's going to be a mare to get apart to actually get down to see what it is, and we don't have anything like this with an obvious fault like a leaking capacitor. We know we've got 5 volts getting to the board, but that's as far as we're going with it. Oops, put that back. I don't want to damage those. If I damage those, it's game over. Because those are the 2 flexes that go to the heads. Very gently get them out of the way and tuck them out of the way. Right, what I'm going to try and do, where is my, there it is. Oh, I'll get a little bit of solder braid and we'll try and get some of that old nasty solder off there. So this is going to be incredibly difficult to do with it in situ. But then again, it would be incredibly difficult to completely dismantle this whole drive and actually then get it working again. Put a little bit of flux down. I want to take off those old legs. We'll go in with the soldering iron. There we go, that's one of them. One of them cleaned off. Let's try the other one. And there we go, that's that one cleaned off. Oh, there we go, got it out. We'll just have to get that bit of the old capacitor off the board. There we are. It's on the end of my soldering iron. Come off. And we've got 2 reasonable pads down there that we can. They've actually not really been attacked by the electrolyte. I think we caught them in time. did catch the end of that socket there, only just on the edge though, so I think we'll get away with it. So we'll have a further clean up round there, make sure any of that electrolyte we can get off. Now the question is what capacitor we've put back in there. I do have some brand new surface mount. We've got the right value. That's a 220. Those are 47 at 16 volts, so that's exactly the right size. Obviously their actual physical size has changed somewhat. These are newer modern capacitors, obviously that's 90s vintage, but we should get one to fit. Our biggest problem is actually soldering the positive side of it because of the amount of room we've got to get in there. Let's see if I've got some tweezers to make this a little bit easier to do. Just bear with me a second folks, I'll just get the bits I need. Right, well I've got some tweezers which will make doing this at least a little bit easier to do. Got a new capacitor out there. What I will do, we're going to add a little bit of fresh solder to that end pad there. You've got to be so careful when you're doing something like this because one touch of one of those disk drive wires and everything's over. Let's just add a tiny bit of fresh solder there. Now one of the biggest problems is I'm left-handed and really I could do with being right-handed for doing this, but let's see how we get on, shall we? Now can you actually see what I'm doing? Not very well. There you go, I'll give you a better view. Right, so what I'm going to do, I'll get the new capacitor, and what I will do is I'll go in, I'll basically going to heat up the solder that I've put on that side there, and then I'm going to introduce the capacitor to it and then bring the soldering iron away like that. And we've actually got a reasonably decent connection there. The only thing I need to do now is just go in on this side and solder like that. And I'll just have to tip this to see if I can inspect that side, but yes, we have got a decent connection there. So that's the new capacitor installed. And I wonder if that's actually going to make this drive function. So what I will do, I'll bring the laptop back in, I'll get it connected back up, and we will see if that's made any difference or not to the actual functioning of the laptop. So back in a sec. Right, we're all connected back up. Obviously we've got that still wound out there, so like I say, I'm hoping that that is going to seep back as soon as we apply power. If it does indicate that we might have actually made some progress by changing that one electrolytic capacitor. So let's try that now. Let's switch back on. It don't look like we've made any progress, unfortunately, in that regard. We will let the computer boot up. I'll put a floppy in. We could of course have a problem with the actual floppy disk controller on the main board. Let's just try A there. And we've got absolutely no activity still. Although I suppose technically we should have a slightly better floppy drive if all that was wrong with that was I can just hear that tick 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 noise like I was last time. Switch off. Disconnect that again. So unfortunately that hasn't ended us up with a working floppy drive, although it's obviously not done that drive any harm to have that leaking electrolytic capacitor removed from it. And I can't see any more in there. There was literally just that one. Unfortunately, I can't vouch for the functionality of this drive because it's one out of an external enclosure that the computer it goes with is long since gone. So that's basically where we're at the moment. Is although we've got the computer basically working now and booting an operating system and everything, we don't have a functioning floppy drive. I will carry on looking through my stuff because I think I might have a couple more older laptop style floppy drives like this. The problem is, if it's not that, it's the actual drive controller on the laptop which is going to be the issue, and I have a feeling that drive controller is built into that Vtech chip there, in which case we aren't getting the floppy drive working on this thing. What we could do though, if we can't get the floppy drive working, we could use that space there for the compact flash. In fact, what we could possibly do is have a second compact flash as a drive, and actually use that for, so it basically show us up as the IDE drive D on the computer, and would allow us to transfer files off and on the actual system. That's actually a good thing we could think about possibly doing. If we can't fix the floppy drive, or if it turns out that the actual fault is the main IC there, it's not actually anything to do with the floppy drive itself, that is an option, as we could do away with the floppy drive, mount some way of actually plugging an SD card in there, sorry, a compact flash card. Or it could even be an SD card. We use an IDE to SD adapter. That's another possibility. So it's not the end of the world that we can't get this working. Like I say, I will carry on playing, and I will carry on seeing if I can actually do anything with this floppy drive. And I will have another hunt round, see if I've got any other floppy drives of this era that we might be able to try in it. It'd be nice actually to find one in a system that's working, that I can pull it, I can test, actually try in the computer, make sure, confirm it's definitely working, then try it in this system, and even perhaps try that floppy drive in another system. I've got one that I might have to go really digging in the attic for it though. Might have something in it that we can possibly use. Anyway, I'm going to leave it there for now. Like I say, I hope you enjoyed this little update on the project. I will be doing another video on this fairly soon, even if it's just to put it back together for the time being kind of video. But a chap has asked me a few questions which I will answer for him in the next video. One is the dimensions on that. He's got, actually it's this computer, but it's branded as a laser. I believe that's fairly standard, that when these were sold in the US and other markets, they were sold as a laser rather than as a Vtech. But essentially it's exactly the same computer as I'm working on, he's working on. He's mentioned that there's basically very, very little of any information on the internet on these things. He's trying to rebuild the original power supply. Like I said, I'm working on a different route, but I think I do still have the PCB out of the old power supply, and I might be able to answer some questions for him. He's missing his battery cover, so he asked me to take some dimensions off the battery cover for him. So I will do that in the next, well, not tonight anyway, but in the next day or two. I'll take some fairly detailed measurements where these little clips and everything are. And to be honest, that should be fairly reasonable to make a reproduction of, that will, look reasonable. I'm sure anyone with a 3D printer would be able to do it, but even if you didn't, if you could cut the plastic, that should be, you know, you'd have to glue it and stack a couple of pieces up, but that little lip there should be makeable, and those little locking pipe pieces should easily be makeable as well. So if we've got access to a 3D printer, it should be very, very easy indeed to make, because it really is quite simple, that. Anyway, that's for the next video. I'm going to leave it there for now. Like I said, I hope you enjoyed this little update on the project, and at least you saw it boot, even if I did have to cheat and make that on another computer. So like I say, I will say thanks for watching and goodbye.